Alright, ladies and gentlemen, let's talk about roots and radicals. Alright, we have our index, which tells us the root. So if there's no number here, it is a square root. So whatever the index is, that is the number of factors that we need to simplify it. So if it's a square root, we're looking for pairs. If it's a cube root, we're looking for trios or triplets. If it's a fourth root, we're looking for sets of 4 and so forth. Our radicand is whatever is under the radical. Okay? Use your calculator whenever possible, especially with the numbers. But recognize if there's a negative under the radical and the root is odd, so cube root, fifth root, and so forth, negatives you will pull out. If it's a square root and negative, such as example 5 over here, we will pull an I out. If you see a fourth root with a negative, remember if the root is even and there is a negative under the radical, then there are no real roots. So that's what you would write. So if we got a fourth root of 81, we could put that in the calculator and get 3 cube root of 81. That's negative 2. This we would say non-real. Okay. Fifth root of 32 is 2. The square root of 121, as we learned before, that is 11i. Okay. So kind of go through the rest of these with the numbers and see if you can do them. Pause for a moment and get that done. So the fourth root of 2,401, that's just going to be 7. Square root of 64, so square root of 64 over the square root of 169 is 8 over 13. Cube root of negative 8 over 125 is just going to be negative 2 over 5. Now we got the square root of 1/3. So the square root of 1 over the square root of 3. So if it's 1 over the square root of 3, we have to rationalize that. So let's talk about that for a moment. So we have a square root under the radical, or in the denominator rather. So we need a set of 2 or pairs to get rid of the radical. So we're going to multiply by the square root of 3 over the square root of 3, because anything over itself is 1. So we're not changing that value. So 3 times 3 is 9. The square root of 9 is 3. So now no radical in the denominator. We never want a radical in the denominator. Never, ever, ever. So our answer is the square root of 3 over 3. Okay. So if we do the square root of 10 over the square root of 12, you could simplify the square root of 12 and make this a little easier so that you don't have to deal with larger numbers. So we could say 10 over 2 square root of 3. So now again, we just got to multiply by the square root of 3 over the square root of 3. So we get 10 square root of 3 over 6, because 3 times 2 is 6. So we would end up with 5 square root of 3 over 3. My pen's struggling to write that. Let's try to erase that and do that again. Oh boy. All right. So let's try some others. Okay. Now, these have numbers and variables. Okay. So we know the square root of 16 is 4. So if it's a square root, we're looking for pairs. So let's take this x cubed for a moment. I'm going to write up here. Let's just say if we had the square root of x cubed. So we got the square root, and I'm going to x cubed. We have a pair, so I can pull one x out, or I can say 2 can go into 3 one time, and there is 1 left over. So there's going to be an x left under the radical. Okay, 2 can go into 8 4 times, so we're going to have y to the 4th. 2 can go into 15 z 7 times, so we're going to have z to the 7th with 1 z left over. Very important that you write your radicals appropriately. So I'm going to rewrite my answer again so that it's a little clearer in terms of reading it. So we got 4x y to the 4th z to the 7th times the square root of x z. All right, now we have the cube root of 64, a, b to the 15th, 8. So cube root, we're looking for sets of 3. Okay, so the cube root of negative 64, we can pull that negative out. Cube root of 64 is 4. There are no 3's in 1, so we're going to leave the a under the radical. Mind you, I need to make sure it stays a cube root. 3 can go into 15 5 times, so we can pull b to the 5th out. And 3 can go into 8 twice, so we got c squared with 2 c's left over. So we got c squared also under the radical. So we got negative 4 b to the 5th c squared times the cube root of a c squared. Fifth root, looking for sets of 5. It's an odd root, negative. We're still going to pull the negative out. But there are no sets of 5 and 6, so that's going to stay under the radical. We got the fifth root of 6. 5 can go into 6 once, so we can pull 1x, and there's 1 left over. 5 can go into 42 8 times, so we got y to the 8th with y squared left over. 5 can go into 24 4 times, so we got z to the 4th. That would be 4 z's left over. So negative x y to the 8th z to the 4th times the fifth root of 6x y squared z to the 4th. Make sure this goes over all of that. All right, we got a quotient, so you can split it. We got the fourth root of x to the 12th over the fourth root of 16. 4 goes into 12 3 times, so we got x cubed over the fourth root of 16, 2. Cube root 27 is 3. 3 can go into 5 once, so we can pull 1x, but we're going to keep that cube root of x squared because there are 2 left over. And 3 can go into 20 6 times with 2 left over, so we're going to keep the y squared under the radical. Now the cube root of 8 being 2, so we only have 2 in the denominator. 6, again, let's split it. Square root of 6, because that can't be simplified. We can pull an x. Well, let's rewrite this and give ourselves some space. So we can pull the next, and 2 can go into 15 7 times. We can pull that. So under the radical, we still have the square root of 6, and we have 1y left over. The square root of 32 is going to simplify to 4 square root of 2. So now we don't like this radical here, right? But we do have this 6 here. So 6 divided by 2 is 3. So we're going to write this as x, y to the 7th square root of 3y all over 4. So probably another way of looking at this problem, I'm going to do it in blue, is to, from the top, we got 6 over 32. Let's reduce that. 2 can go into 6 3 times. So we got square root of 3 over 2 can go into that 16 times. So we've reduced that. So here's our square root of 3, and square root of 16 is 4. So you could have done that from the beginning as well, and it would have worked out the same. Okay? All right. So go through the worksheet, complete those practice problems. Let me know if you have any questions.